All right, we're back again. Justin here, chemistrynotes.com, and this is section 3, chemical quantities and stoichiometry, and we are on video number 2 for that section. So in today's video, I'm going to cover two things. I'm going to cover molar mass and how to calculate molar mass, and then I'm also going to talk briefly about how to calculate mass percent. Now, mass percent is also referred to as percent composition. All right, so molar mass. Well, quite simply, it's the mass of 1 mole of a compound. Often referred to as molecular weight or formula mass. I almost always refer to it as molar mass, but you might hear me say molecular weight. Every once in a while I might say formula mass, especially if we're talking about ionic compounds. But molar mass is really almost identical to calculating atomic mass. You don't even calculate atomic mass, right? You just look at the periodic table, you find the decimal number, and that's the element's atomic mass. For example, carbon, 12.01 grams per mole. Well, compounds and molecules have a molar mass, not an atomic mass, because compounds aren't individual atoms. Let's do an example. It should make lots of sense. If you have a periodic table in front of you, this will be very kind of intuitive. We have a certain chemical dye, has the formula C10H6O3. So in A, they want me to calculate the molar mass. So essentially, I'm going to have to add up 10 carbons, 6 hydrogens, and 3 oxygens, right? Well, we're going to need the periodic table because maybe some of us know the atomic masses already for guys like carbon, hydrogen, and oxygen. Some of us don't. So I made a little grid here, 10 carbons, 10 times 12.01 grams per mole, 6 hydrogens, 6 times 1.01 grams per mole. The stuff in parentheses, those are the individual atomic masses of carbon, hydrogen, and oxygen going down. Okay? If you add all these up, and I like to report my atomic masses and molar masses to the hundredths place, I just do, 174.16 grams per mole. This is the molar mass or molecular weight of C10H6O3. Right? So that's kind of I don't want to say no-brainer, but if you know what atomic mass is, it should follow suit that getting the molar mass or the molecular weight is just a matter of being careful with your calculator. All right, here's part B of that same sample problem, top of page 2. How many moles of C10H6O3 are contained in 1.56 times 10 to the minus 2 grams of the dye? Start with what you're given, put it over 1. This is stoichiometry again, right? We use stoichiometry all day long in this course. Okay? Well, I mean, it's basically dimensional analysis. Stoichiometry technically is when we have reactions, when we go from reactants to products, reactants to another reactant. But this is the backbone and the way that we do stoichiometry when that time comes. Okay? So I should correct myself there. But we started with grams. We've got to get out of grams. That's why the 174 is on the bottom, and then the 1 mole is on top. I essentially divided by the molar mass to get 8.96 times 10 to the minus 5th moles. Started with 3 sig figs, ended up with 3 sig figs. Okay? Another example problem. Isopentyl acetate. Luckily, they've given us the formula, right? C7H14O2 gives bananas their smell. That's great. That's just superfluous information. Let's hone in on what's important. We've got 1 microgram of the compound. We want to go from 1 microgram to molecules. And then once we've got molecules, we can do the second part of the question, which is how many carbon atoms. First things first, 1 microgram. Do you remember that? That's a metric conversion. We got to get from micrograms to grams. Okay? And then once we get to grams, we have to use the molar mass to get to moles. And then from moles, we're going to go to molecules. That's our plan. Can't do anything without the molar mass. 7 carbons, 14 hydrogens, 2 oxygens in the formula, right? Add up the individual atomic masses, multiply by 7 for carbon, 14 for hydrogen, 2 for oxygen, 130.21 grams per 1 mole. That's the molar mass of isopentyl acetate. Now we can start with what we're given and put it over 1. We're not given much. We're given 1 microgram. I'm not just going to write 1 microgram. I'm going to write 1 microgram of IA, isopentyl acetate. If you want to write C7H14O3, you can do that too. 10 to the 6 micrograms is 1 gram. That gets me out of that yucky micrograms into grams. Divide by the molar mass, so I got 130.21 grams on the bottom for every 1 mole of isopentyl acetate. They don't want moles, they want molecules. Well, 1 mole of anything contains 6.022 times 10 to the 23rd items of that anything. We're talking about a molecule, so it's molecules IA. 4.62 times 10 to the 15th. We started with 1 sig fig, which limits the way we can report our answer. 5 times 10 to the 15th molecules of C7H14O2. Okay? Everything from the beginning to the end, when we get our answer, is a conversion factor, and we assume conversion factors have an infinite number of significant figures. That's why I always say the number of sig figs we start with is the number of sig figs we end up with. Okay? Now, to do the second half of the question, we start with what we're given and put it over 1. This time we're kind of, quote, given our answer from the first part. 5 times 10 to the 15th molecules of IA. Well, 1 molecule of C7H14O3, look at C7, contains 7 carbon atoms. You just multiply our answer from above times 7, apply proper significant figures, and it's 4 times 10 to the 16th atoms of carbon. Okay? All right, so that's molar mass. Now I want to briefly talk about how to determine mass percent. And then in the next video, we'll go into something called empirical and molecular formula. Determining mass percent. Mass percent defined as an element's percentage of the total mass of a compound or molecule containing the element. Okay, it's also called percentage composition. Sometimes it's called mass percent composition. Okay, the two most popular are mass percent or percent composition. Sometimes the wording will say calculate the percent by mass. Same thing. All right. Well, the best way to explain how to calculate mass percent or percent composition is just by doing an example. So we use isopentyl acetate, C7H14O2. Okay, we already had its molar mass, so we'll use that one. We added up 7 carbons, 14 H's, and 2 oxygens, and we got a molar mass of 130.21 grams per mole in the previous problem. No longer do we call that 130.21 AMU. We don't like AMU as much. All right, well, what's the mass percent of carbon? It's just the mass of carbon divided by the total mass times 100%. So carbon's contribution to the 130.21 grams is 84.07. So 84.07 grams per mole divided by 130.21 grams per mole times 100, 64.6% carbon. Now let's do hydrogen. Hydrogen weighs only 1.01, so we should always expect low contributions to mass percent from hydrogen. 14 times 1.01 is 14.14. Divide that by the total mass, 130.21, and we get 10.9% hydrogen. 14 hydrogens we had in that molecule. Still only contributes just under 11% to the total mass. Okay, now I could do the exact same calculation for oxygen, and I would end up with 24.5% oxygen, or I could just understand that 100% minus those 2% leaves the only atom that's left, the only element that's left, oxygen, 24.5%. Oh. In the next video, which is going to be section 3, video number 3, chemical quantities and stoichiometry, is the quote-unquote chapter 3 that we're in. We're going to talk about how to determine empirical and molecular formulas. So that video, the next video, is devoted to empirical and molecular formula. Check that out. You don't want to miss it, and I'll see you soon.